Happy Wednesday, everybody. Today we are going to continue talking about what causes our ocean currents. So, starting off, let's just talk a little bit about the Earth being tilted. So, in our Explore activity on Monday, you guys analyzed this graphic and did great. You can see that our sunlight, because our Earth is tilted, we have our sunlight most directly hitting on the equator. So you can see this circle is the smallest. If we are looking at this graphic right now, so the Earth, this is showing that it is tilted, and you can see that direct sunlight is hitting right now in the southern hemisphere. So it is summer in the southern hemisphere. In comparison, when the Earth is tilted towards the sun like this, the northern hemisphere is having summer, and that is because the sunlight is more directly hitting that area. So here, if we look, our low angle of light is now in that northern hemisphere. That sunlight beam, instead of being really direct, it is now hitting a larger surface area. So that means that it's going to be a lot cooler. Okay, so more direct sunlight causing the Earth to absorb more thermal energy. Indirect light causes it to absorb less. Okay, so that's just a basic thing to understand before we start talking about oceans, because the oceans, you find the same process. Before we keep going, predict if you have cold water and warm water, what would happen and why? Pause the video and talk to yourself. So maybe in your explanation, you talked about cold water being more dense, warm water, hot water being less dense. And this is everything when it comes to how water interacts. So the first thing that causes our ocean movement is the temperature of the water. So cold water is going to sink as it is more dense, and warm water will be rising as it is less dense. And this is going to be causing a current. It's just either a moving mass of either a liquid in this case, or when we talk about weather, it will be a gas. Take a look at this image. What do you guys notice? Where is there the most warm water? And where is there more cooler water? Maybe you notice that there's a lot more warmer water originating around the equator. That's because there's more direct sunlight consistently around the equator. So you can see we have this warm water moving up, then it's going north and it cools and it sinks, and then it moves towards the equator, warm rises, and this is our convection current. Okay, this is why when you go to like Florida, East Coast, it's really warm and it's really nice ocean to swim in, versus if you go over to the West Coast, California, it's a lot cooler over on that side because we have the water coming down from this more northern area and it is cooler. So next, take a look at this video that shows you how this works.
Have you heard that heat rises? Well, here you can see it's true for yourself. I've got some food coloring on the bottom of a plastic container, and there's a hot mug right underneath the red food coloring. As it's heated, the water rises. But I want you to look closely and notice something else. The blue on the sides is being drawn in. You can see it better when I speed it up. Here's the thing I want you to remember. When water moves from one place, it doesn't leave a void behind. Water from somewhere else has to move in to take its place. That's why you can see the blue food coloring coming in from the sides. You can see it better from above. Watch that blue food coloring get drawn in. Do you see it? water reaches the top, and then it gets pushed toward the edges by more hot water rising from underneath it. As it goes out to the edges, it starts to get cool, and cool water sinks just as hot water rises. And if you watch really carefully, you can see it sink and get drawn back toward the middle. These are called convection currents, and you see them moving here in two big ovals. They're one of the major things that drive ocean currents, especially in the deep oceans. But it's not hot water rising that drives the ocean currents. It's really cold water sinking up near the poles. Here's a piece of ice that I froze with some blue food coloring in it, so you can see how cold water sinks. As water sinks at the North Pole, for example, water has to flow up from southern regions to take its place. And these currents travel around the globe, some of them taking 1,000 years to complete their course. Understanding convection currents will help you get a grip on weather systems and the movement of Earth's continents over the eons, and even the workings of a lava lamp. If you want to try this...
Okay, so temperature has a big impact on our ocean currents. The other thing that plays an impact is the salinity of the water. So just talk to yourself, predict. If you have a water that's very salty and water that's less salty, what will happen when they interact and why? Pause the video. Okay, so you might have looked at these pictures to help you in your answer. So here we have just regular water, and here is salt water. You can see that salt water is going to be more dense. There's more molecules packed into the same amount of space, so the density is increased in compared to regular water or even lightly salted water. So when we're talking about salinity, salinity is the saltiness or dissolved salt content of a body of water. And how salty a water is just caused by erosion of land, which deposits the salt into the water. And due to the differences in saltiness, this can cause currents as well. Okay, so here you can see we have our warm water. It's traveling up towards the poles. Once it gets towards the poles, it's a lot colder because there's less direct sunlight. So as a result, ice forms. Ice, we know, is not salty. So what happens is when ice is formed, the surrounding water becomes more salty because it's just the water molecules that are freezing. So because more and more ice is forming, that means that there's more and more just salty water left behind. That extra salty water then is going to sink and then is going to be moving. Okay. Let's take a look.
Stick divider and see what happens.
So here you can see this was the salty water, this was the less salty water. Let's see what happens.
Denser blue water quickly flows under the less dense yellow water. Then we get an internal wave sloshing back and forth. You can see the surface is calm. Internally, between the two different densities, we get a wave that sloshes back and forth. And we get the divider. Separate the two sides again. We can mix one side and see.
So you can see now this green water is going to be right in between the salinity of the yellow and the blue water. What do you think is going to happen when they lift up the divider?
What the intermediate density water does. See that it forms an intermediate layer between the densest blue water on the bottom and the less dense yellow. Layers may also be mixed by tidal mixing over a or shallow shelf. And we can put our finger in slowly, and we feel the very warm water on the top and the much cooler water on the bottom with our finger. Very easy to feel the difference.
So in that video, they had a difference in saltiness and temperature, which is just like the oceans. Okay, so on the rest of the assignment, I have linked 2 videos that demonstrate convection currents that you can try at home. I didn't put any questions with these videos because they are a little bit more material specific, and I understand that not everybody has the materials, so if you can't do the experiments, that's okay. You can just watch the videos. If you can, awesome, comment in the comments what worked, what didn't work, which one did you do, and a useful tip for trying these experiments, if you don't have food coloring like I don't, just use a marker and kind of swirl around your marker into your water to change the color. Anyway, hope to see you guys at our Zoom later today. Have a good rest of your day.